Well, I don't see nowhere to give y'all permission.
You can, if you have an iPhone, you can just push screen record on your screen, like from your.
Yeah, I'm using my laptop.
Oh.
You use your iPhone.
Yeah.
Oh, no.
And I'm gonna record it, and I'll send you a cloud recording of it.
Okay. Thank you.
Okay. All right, so I don't see no one else waiting, so I'm gonna get y'all started. So I'm gonna go to my screen and share. And what we're gonna do to start out, we're gonna finish up 8.4 because I had gotten y'all down to about number 14 on it. And this is still about theorems about zeros still. So we're going to find what we call all irrational zeros. So to find all rational zeros of a polynomial, we find all factors of P divided by Q. Y'all, P is going to be all factors of the last number, and then Q is all factors of the first number. So this just gives us a little way to find zeros that we could test using synthetic division instead of having to check every possible number there is. So we can sort of eliminate numbers that we don't have to check in our synthetic division, because that could take a long process if you had to keep checking all the numbers. So it's all the factors of that last number divided by all the factors of the first number. So what I'm going to do, I'm going to find all possible rational zeros of P of X equals 10x to the third minus 34x squared plus 46x minus 21. So we're looking at the ratios of the P's over the Q's. So P is going to be 21, since that's my last number. And then Q will be all the factors of 10, because that's my first number. So let's find factors of 21. Could be 1, 3, 7, and 21. Factors of our 10 will be 1, 2, 5, and 10. Now remember, all these could be positive or negative, so when I find my actual ratios, I'm going to be finding the positive or negative factors of P over all my Q's. So let's see, we got 4 factors of P. All 4 of these factors got to be divided by all the factors of the Q. So I'm going to start with my 1. So plus or minus 1, I'm going to take that 1 and divide by 1. But y'all, 1 divided by 1 just gives me 1. So I divided by the 1, now I got to divide by the 2. So I got plus or minus 1 divided by 2. That one doesn't reduce, so I stop there. Then I take that 1 divided by the 5. So I got plus or minus 1 divided by 5. That one doesn't reduce. And then finally I take that 1 plus or minus 1 and divide by the 10. All right, so that doesn't reduce. So at the moment I got plus or minus 1, plus or minus 1/2, plus or minus 1/5, and plus or minus 1/10 that are possible zeros. So now I got to do the same thing with the 3. So I'm going to take plus or minus 3 and divide that 3 by all 4 numbers. Well, when I divide by 1, I get plus or minus 3 because I can simplify that. So that's with the 1. Now I'll take the 3 and divide by 2. That one doesn't simplify. So then I take the 3, divide by 5. That one doesn't simplify. And then finally take the 3, divide by 10. All right, so that doesn't simplify. So at the moment, I've got 2, 4, 6, 8, 10, 12, 14, 16 possible zeros. Now we got to move to the 7. So plus or minus 7 divided by the 1 gives me a plus or minus 7. Plus or minus 7 now divides by the 2. So that doesn't reduce. Plus or minus 7 now divides by the 5. And then finally, plus or minus 7 divides by the 10. All right, so that's 3 of those factors done. So now we got to work on the last one, which is our 21. So here we go. Plus or minus 21 divided by the 1 gives me a plus or minus 21. Plus or minus 21 divided by 2. That one don't reduce. Plus or minus 21 divided by 5. That one doesn't reduce. And then finally, plus or minus 21 divided by my 10. So all these are not zeros, but we're guaranteeing that the rational zeros is one of these numbers. Okay, so I wouldn't have to check numbers like 2, 4, 6 because they're not factors that I can get out of them 2 numbers. Okay, and I'll show you on the homework. Here's how they list it. So you notice you just got to go through and find the one that's got all the numbers you've had on it. Okay, so I had a 1, 3, 7, and 21. So 1, 3, 7, 21. But remember, R's got to be plus or minus. So you wouldn't even pick A at all because none of those had the plus or minuses, okay? So there's my 1, 3, 7, 21. And then I had 2 on the bottom, 5 on the bottom, and 10. But notice these got 3 7s and 21. So those ones were out of order. So the one that had the bottoms I need would be C. Okay, so you just got to go through it and find which one has all your fractions and your whole numbers. See, the reason they did that is so when we start doing these problems like number 16, you don't spend all day trying to find some zeros to start with. So these are the tricky ones. They want us to find all zeros of f of x equals x to the third minus 111x plus 110. Then once I find all the zeros, they want me to factor this into linear factors. So that just means they want me to put them back into parentheses instead of just having them final answers, okay? So we're going to find all zeros. So my last number is 110, so that would be my P. And my Q would equal my first number, which is a 1. So what all I need on this problem are all the factors of 110. So I'm going to use my calculator to help me. So if I hit program, y'all, and go to factor 2, so on mine, it looks like it's number 9 option, factors 2, and hit enter. And then hit enter to start it. I want all factors, so I'm going to hit enter. And the number I want factors from is that 110. So let me put in my 110 and enter. So all the factors of 110 are going to be 1, 2, 5, 10, 11, 22, 55, and 110. And remember, all of them could be plus or minus. Okay, now I don't want to do synthetic division up to, let's see, 2, 4, 6, 8, 10, 12, 14. I don't want to do synthetic division 16 times. So I'm going to graph this on the calculator so that it can narrow it down for me. So I'm going to go to y equals, clear that, and I'm going to put in my x to the third minus 111x plus 110. And hopefully I can see where this graph is crossing over the x-axis, because that'll be my zeros. So let me hit graph. And y'all, if you look, it looks like that one does sort of cross over at the +1. So my first zero I'm going to try is going to be that +1. And if you want to make sure, you can go to second graph and go to your chart. And let me pull down here at a +1. And if you see it +1, it was in fact a 0. So +1 will be my first number. Now to do synthetic division, I got to write all my coefficients out. So for the x3, I got a 1. I do not have an x squared term in that polynomial, so the x squared term has to be a 0. My x term is -111, and then my last number is the 110. So any exponents that are missing up here got to be 0 down here in your synthetic division. All righty. If I pick the right number, my remainder better be a 0 in that box when we're done, okay? If not, I'll have to try another number. All right, so y'all, let's check. The first number 1 goes straight down. And then you take that 1 times the 1 for your C. So 1 times 1 is 1. Put that under the 0. Then you're going to add those together. And 0 plus 1 gives me 1. Now we're going to take 1 times 1 and get 1. We're going to add this row now. -111, +1 gives me a -110. And then I take that -110 times that 1, and I get a -110. So now 110 minus 110 gives me a remainder of 0. So you see, by graphing it, I was able to find one of my zeros, and that kept me from having to check a whole lot of numbers. So y'all, since this was an x3, I need 3 zeros. So my first 0 for sure was that 1. Since I got 3 numbers left here, I can now use the quadratic formula, get my last 2 zeros. So you got to have it down to 3 numbers. Use your quad. So remember to use my quad. I can go to my program, go down to quad. Hit enter on quad and enter. So now remember, A will be 1, B will be 1, and C will be a -110. So here we go. 1 enter, 1 enter, -110, enter. And looks like my X is equal a 10 and a -11. And y'all check out this. 10 and 11, since those are real numbers, would have been 2 more possible factors up here. Let's see, there's my 10 and 11. Remember, they could be positive or negative. So my last 2 zeros would be 10 and what do we say? -11. Now I know I'm done because my degree was at 3. And I got my 3 zeros. All right, so y'all plug them on that calculator and let it sort of guide this a little bit, okay? All right, y'all, here comes another one. Oh, no, hold on. Let me put these in linear factors.
Oh wait, A, B, and C are 1. I mean, A and B are 1 on the last first one.
Do what now?
Like it's okay. No, I figured it out. I see what you're getting. I just
Okay.
watched.
So now for linear factors, they're going to have f of x equals, and then we got to put the answer in. So since we got 3 zeros, we need 3 sets of parentheses here. And what happens when you put them into linear factors, all we do is change the signs of our answers. So since that was a positive 1, we do x minus 1. Since that was a positive 10, the factor will be a x minus 10. And then since the last one was a negative 11, this will be x plus 11. So what they want you to realize is that when it's in factor form, the numbers are always opposite in sign than your answers or your zeros are, okay? All right, so y'all keep me reminding me, because we got to do part A is finding the zeros, and then part B is putting them as these linear factors. All right, now I can move on to that next one.
The linear factor.
Yeah, linear factors, you
The
just
linear factor.
putting them back into those parentheses.
Okay. That's all it means.
You remember like the other day when we was finding the polynomial degree 3 with the following zeros, and we
Yeah.
set them equal, and then we had to get a 0 on them, and then we put
Mhm.
them all into parentheses. It's sort of doing that going backwards.
Okay. So now we're finding the zeros, basically.
Yeah, we're finding zeros, and they're not giving us any to start with.
Oh, because they did give us numbers to start with last time.
Exactly. So that's why you had to learn about those rational zeros, was to know
Okay.
what numbers we could check for. All right, so I got 2x to the third plus 7x squared. Oh, that's plus a 98x plus 343. So we're going to find all zeros and then put into linear factors. So first thing I'm going to do is find my p's and my q's. So p would be 343. So let me find my factors of 343 on my calculator. I'm going to hit program, go to factor 2 for all the factors, hit enter. All right, I want all factors of 343. Y'all, when I hit enter, I get 1, 7, 49, and 343. And all those could be pluses or minuses. Now my Q is the first number, which is a 2. And the factors of 2 would be 1 and 2. So I'm going to write all my possible factors first, because that could be anything with a P over Q. So that could be a plus or minus 1 divided by 1. So I'm going to take the 1 divided by 1, which is a plus or minus 1. And then I can take that 1 and divide by that 2. Cannot reduce that one. So then we take the 7. Plus or minus 7 divided by 1 is a plus or minus 7. And then 7 divided by the 2 does not reduce. Then we would do that with the 49. 49 over 1 is just a plus or minus 49. And then 49 over 2 does not reduce. And then finally do that with that 343. So 343 over 1 is a 343. And then 343 over 2 does not reduce. Now, I don't know which one of these numbers I'm going to start with, so I'm going to go and graph that so that the calculator can give me a little bit of help on that. So I'm going to go to y equals and clear that one. So I'm going to put in my 2x to the third plus 7x squared plus 98x plus 343. And then, y'all, I'm going to hit graph to see where it looks like it's crossing that x-axis at. So if you notice on this one, it's not going to cross no numbers, but it looks like it's at a -1, -2. It's in between -3 and -4. So I'm going to figure out which one of these fractions looks like it might be between a -3 and a -4. So 1/2 is just a 0.5. That's not it. Oh, y'all look at that, 7/2. If you take 7 and divide by 2, you would get a 3.5. And that does look like it's at about a -3.5. So my first zero is going to be a -7/2. All right, 49 divided by 2 would be like 24.5. It would be way to the left. And y'all, that 342 divided by 2 would be like a -170 or so. So it would be even way further to the left. So if you need to, just sort of figure out which one of these fractions reduces to about a -3.5 like we had. All right, so now that we got the -7/2, we're going to write our coefficients, which is a 2, a 7, a 98, and a 343. So no zeros this time because every placeholder was there. All righty, so let's see. If we're right, that's going to be a 0 when we're done. So bring that 2 down. So y'all, let's see. -7/2 times a 2. When you multiply them 2's cancel. So that's just going to give me a -7. 7 and -7 give me a 0. 0 times -7/2 is 0. Let's see, 98 plus 0 is 98. And then if you need to, ask that calculator, what is a 98 times a -7 divided by 2? That's going to give me a -343. And y'all look at that, 343, -343, give me a 0. So I know my first 0 is going to be the -7/2. All right, to find the other 2, since I got 3 numbers left, I'm going to use quadratic formula. A is 2, B is 0, and C is 98. So I'm going to go to my program and go to my quad.
So they don't even give you the -7/2? They don't give you that, right?
No, we had to find that because it had to be one of our possible zeros up here.
Uh-huh.
So I just had to use that graph to see which one of these it was closest to.
Okay. Dang, that's intense.
So those won't be your trickiest ones is those last 2 or 3 on here, okay? And I got an even trickier one coming up, so. All right, so let me quad that. Let's see, we got a 2, a 0, and a 98. And that's a +7i, -7i. So I'm just going to write that as x equals 7i, x equals a -7i. So your 3 zeros are the -7/2, 7i, -7i. But remember at the end, they want me to write these as linear factors. So they'll give us the f of x equals, and we got to put all these in parentheses. So I got 3 parentheses. So since that's a -7/2, we're going to make that a +7/2. Since that's a positive 7i, we're going to make that a negative 7i. And then since that's a negative 7i, I'm going to make that a positive 7i. Now, y'all, this one goes one step further. Since there's a fraction in here with a 2 on the bottom, we also have to write that number out front of our final answer. So that this would equal 2 times x plus 7 halves, x minus 7i, and then x plus 7i is my final answer. I get my pages turned from the next one. All right, let me write. Can y'all see all that?
Mm-hmm. Can you go down like just a little?
Like that?
Yeah, it's loading. There we go.
All right, so it looks like about all y'all are ready to get this last one right.
All right.
So what we do when y'all get good at finding 3 zeros, we just pop out a 4th one. How about that? How about f of x equals x to the 4th minus 10x to the 3rd minus 6x squared minus 94x minus 39. We want to find all zeros. And then write in linear factors. Now notice, my first number is a 1, so I'm really not worried about a 1. So all I really need to find is all my factors of that 39. So factors of 39 would be 1, 3, 13, and 39. Because remember, all the Q has is a 1 on the bottom. So the numbers I'll check are positive or minus 1, positive or minus 3, positive or minus 13, positive or minus 39. But y'all, I don't want to have to check 2, 4, 6, 8 numbers. So once again, I'm just going to graph that and see where this thing crosses over that axis. So let me turn this on. I'm going to clear that one.
So we're about to graph this.
I'm going to graph it and see if I can see where it's crossing that x-axis at. So I got x to the 4th minus 10x to the 3rd minus 66x squared minus 94x minus 39. So let's graph that and see where it's crossing the x-axis. Well, I got 2 I can hit right there, don't I? This one looks like it's touching at about a -1, and this one's actually crossing all the way through at a -3. So I can use any of those numbers. So since that one's crossing through that, I'm going to use that -3 first. So let me write down my coefficients, which are 1, -10, -66, -94, and -39. And remember, if I'm right, my remainder will be 0 on this, okay? All right, y'all, so here we go. We're going to bring our first number down, 1. 1 times -3 is -3. -10 plus a -3 was a -13. Negative 13 times negative 3 is 39. So negative 66 plus 39. What's that give me? Negative 27. Negative 27 times negative 3 is a positive 81. There you go, because that's what, a negative 13? Negative 13 times negative 3 gives me 39, and I got a 0 remainder. But y'all watch out. Remember, I got to get 4 zeros. I got the first one, which is that negative 3. But I can't use quad yet because I still got 4 numbers. So since I got 4 numbers, I'm going to write those 4 numbers down. And we're going to have to use the synthetic division again. So, hell, what number can I use next? So
Negative or positive 3.
Downstairs.
all right, what's my graph hitting? So we did that negative 3. So what about this one right here? That's at a negative 1, ain't it?
Yeah.
Let me show y'all my table. If you hit second graph, so there's a negative 3. See that y was 0? And then if you come down here at negative 1, that y value is also 0. So anything that has a y value of 0 is what we want to use, okay?
Okay, that makes sense.
All right, so here we go. We're going to bring the 1 down. 1 times negative 1 is negative 1. Let's see, negative 13 plus negative 1 is negative 14. Negative 14 times negative 1 is a positive 14. Negative 27 plus 14 is a negative 13. Oh, and y'all look at that. Negative 13 times negative 1 is a positive 13. And that gives me what? A 0 remainder. So negative 3 is a 0. Negative 1 is a 0. You now have 3 numbers left. So since I got 3 numbers to get my last 2, I'm going to use the quadratic formula. So you can always use that quad to get your last 2, okay? So A is 1, B is negative 14, and C is a negative 13. All right, so let me go to quad. Enter, enter. So I said a 1, negative 14, and a negative 13. So I don't want the decimal, so I hit enter one more time. And it looks like I'm getting x equals a 7 plus the square root of 62, and x equals a 7 minus the square root of 62. So all 4 zeros would be the 7 plus square root of 62, 7 minus square root of 62, the negative 1, and the negative 3, which gives me a total of 4 zeros.
Thanks.
Now, the fun part on that is the linear factors. So they're going to give me the f of x equals, I had 4 zeros, so I'm going to have 4 parentheses. Now, this one, since I didn't have any fractions, I don't have to put nothing out front, okay? So here's the minus 3. I'm going to change the sign and make that a positive 3. Negative 1, I'm going to change the sign and make that a positive 1. And y'all on these, we're going to change the sign of the 7, so that's going to give me x minus 7, and change that to a negative square root of 62. So I change both the signs. And on this one, I'm going to change both the signs, so I get x minus 7 plus square root of 62.
That looks so weird.
Yeah, because y'all ain't used to messing with the radicals, really.
Yeah.
So, yeah, might see that kind of factoring in calculus if you do that, maybe. That's why they're not making us factor those. They're just making us
Okay.
use that one to get them kind of zeros, okay? Alrighty, y'all, that takes 8.4.
On 8.5 now.
How about 5.1?
Oh, 5.1. Excuse me.
My hand hurt. I was right.
For real.
Hey, y'all gonna be happy on 5.1. Because 5.1 is just a review of what y'all have already done.
When is our first test?
Say again?
I mean, not our first test, but when is a test? When is our next test coming up?
So I'm thinking that this test, I'll be able to give y'all after next Wednesday so that y'all have the whole weekend to do it. Not this Wednesday, but the next.
Nick.
hmm
Okay.
I'm hoping next Wednesday is a review day for the test.
So you're saying maybe the 22nd or the 15th?
Yeah.
Because,
Because today's what, the 8th? I mean the 6th?
yeah. Yes.
Okay,
yes.
so let me think. The 6th is today. So I'm thinking the 15th.
Okay.
The 15th we'll review for the test the 15th, and y'all will take that, okay?
He's like, make sure you file your taxes. No, I think they extended it, didn't
It's July the 15th.
they? Yeah. People still gonna be late.
Me. 'Cause I owe.
Hey, y'all, so 5.1, they start out with questions. They want to find all numbers. For which the rational expression is not defined. So to find numbers that make a rational expression undefined is what they're basically talking about. So let's see, we got a 3c squared minus 10 over 12c plus 25. Really, this is the process we did to find domains earlier in the year. So to find the domain of this, I would have what? Took that 12c plus 25 and set it equal to 0. We're only
0.
worried about the denominator. So that is definitely denominator only. Okay, we don't worry about the top on these problems. So now to solve that for the c, I'm going to start out by subtracting 25 from both sides. So I get 12c equals a negative 25. And then to finish this out, divide both sides by the 12. So that c equals, let's see, 25 and 12, that don't reduce. So my final answer would be a negative 25 over 12. So you don't have to do domains with this. On the first two questions, they just wanted you to find numbers that made it undefined. They don't want us to go no further. All right, so this one's the same thing, but they're giving me a x squared minus x minus 1 on the top. On the bottom, I got an x squared minus 14x plus 45. So once again, we're only worried about that denominator. So I'm going to take my denominator, x squared minus 14x plus 45, set it equal to 0. Now, since y'all don't like factoring, since that's 3 terms, I'm going to use quadratic formula. Anytime you got an x squared equation with 3 terms, you can use the quad. A will be 1, B will be negative 14, C will be 45. So let me program here, go to my quad, hit enter, and enter again. So I had a 1, negative 14, and a 45. So that gave me what? X equaled 9, and X equals 5. Now, if you wanted to, you could have factored that and then set all them equal to 0 and got them same answers, but either way. All right, so the first two, they just wanted me to find the numbers that made them undefined. Now they really do want us to find the domain of each. Which all the reason they showed us those 2 problems is because you're doing that to find the domains. So y'all, you got a f of x equals 6x minus 5 over x plus 4. So since I just got one x down here, I only need one number. So set that x plus 4 equal to 0 and solve that for the x. So really the only thing we got to do there is subtract 4 from both sides so that we get x is a negative 4. Now, we're going to use set builder notation first. So in set builder, they'll give you the parentheses, x such that x is a real number and x is not equal. Pick the one that has not equal in it, okay? Because remember, our x cannot equal negative 4, or that'll make that a 0, which is undefined. So we would put the not equals negative 4, because they'll give you one of these with a regular equals, and that one will give you wrong, okay? Now, you also got to write the interval notation for these answers. So interval notation, we're going to use our parentheses. Our domain starts at negative infinity. We go through all the x's until we hit negative 4. So since it cannot equal negative 4, we're doing a union around that negative 4. And then from that negative 4, it could go all the way to positive infinity. So these answers will start with a negative infinity, end with a positive, and you just got to kick out each number that you get on your answers, okay? All right, so let me let y'all catch up on that.
Thanks.
It looks like most of y'all are done with that.
Mm-hmm.
All right, same thing, finding the domain. This time I got g of x equals 9 over 3x minus x squared. So once again, I'm going to take my 3x minus x squared, set it equal to 0. Now, I want to be able to use my quad and stuff. So what I'm going to do is rearrange this. I want to rearrange it so that my highest exponent's first. So that's that negative x squared. Then my positive 3x, and set all that equal to 0. Because now that I'm in order, I'm going to use the quad. A on this one will be a -1 since that's a negative x squared. B will be a 3 because that's my x term. Oh, I don't have a number, so it has to be 0 at the end, okay? So anytime you don't have that single number at the end, that makes C a 0. So now we can hold program quad. Enter, and then enter again. So we had a -1, +3, and a 0. And it gives me what? X equals 0 and x equals 3. So I now got my two numbers I got to kick out of the domain. So set builder notation, x such that x is a real number. And x is not equal to a 0, 3. Interval notation, we would start with our parentheses. So remember, you always start at -infinity. So going right, which number are you hitting first? If I'm going to hit what? Going left to right, I would hit my 0 first. So I'm going to union around 0 because I can't equal 0. Then from the 0, I would cruise on the x's until I hit the 3. Union around the 3 because we cannot equal 3. And then since I got both my numbers now in my interval, from 3 it's going to go to +infinity. No, these aren't bad. That's the trick on these is just set that bottom equal to 0, find those answers ever how you got to, and then graph it. Now, if you like graphing, I'll show you this. Graph it. So let me clear that. Now, I'm only going to graph the bottom part because that's all I was worried about. So I'm going to do the 3x minus x squared. And I didn't even put it on order on that, okay? I just want to see where that graph crosses that x-axis at. And look at that. Looks like it's going right through the center on that one, which is my 0 answer, right? And then this one looks like it's crossing right at that 3. So if you don't like factoring, you don't like doing the quadratic formula, graph it and see where it crosses that x-axis because that'll be your answers, okay? So y'all got many ways to play with those answers. Ooh, look at this one. On top, it's got an x to the 3rd minus an x squared plus an x plus a 4 all over x squared plus 13x plus 36. Oh, we're glad we don't have to mess with that top on this one because that's 4 terms and we don't like that grouping stuff. So all I'm worried about is the bottom. So I'm going to set the bottom equal to 0. And then solve that using my quad. So let's see, A is 1, B will be to 13, and C will be 36. Now, y'all, the main thing, if you notice, when you're using that quad, everything's got to be in order, and you always got to have a 0 on that other side, okay? All right, so let me go to program, go to quad. And then enter. So I had what, a 1, 13, and a 36. So it gives me what, a x equals -4, x equals -9. Now y'all watch out on this one. It's got x such that x is a real number. And x is not equal to blank blank. Here's the trick on this one. They wanted these answers in ascending order. Ascending order means going from the smallest number to the highest number. So my answers were -4 and -9. The smallest number would be the -9. So it's got to go first, and then the -4 has to be second. Okay? So if you put your answers in and that's wrong, then rearrange them and try again, okay? Now, interval notation starts at -infinity. From -infinity, it cruises till it hits -9. And that's the reason they wanted y'all to put them in ascending order here, so that you would have them in the right order when you got down to this. All right, union from that -9 to that -4. Union from that -4 to positive infinity. Hey, y'all got that?
Mm-hmm.
All righty. All right, that was all of 5.1. So now 8.5, I'm basically just going to give y'all definitions so that when we come back Wednesday, we can get into actually finding these asymptotes. This deals with rational functions. So we're still looking at these fractions, okay? So it starts out with doing a couple domain problems, but that's just like we did in 5.1. So what I want to do is get into some definitions. So the first one is a vertical asymptote. Asymptote, ever how you want to say it.
The A word.
Yeah, when I get tired, I'll just call that a VA. How about that?
That's cool.
But what a vertical asymptote is, I'm gonna pull it over a little bit. It's an imaginary vertical line that occurs where a rational function is undefined. So it's just an imaginary vertical line that occurs where a rational function is undefined. They come in the form of x equals some number. Now, to find the vertical asymptotes, we set the denominator equal to 0. So y'all, finding a vertical asymptote is the same thing as finding domains. You take the bottom of the fraction, set it equal to 0, and then your answers will be x equals whatever number, x equals whatever other numbers, okay? Same thing. Then we got horizontal asymptotes. So I guess I'll call that a HA when I get tired, okay? It's sort of the same thing. It's an imaginary line that the graph tends to approach over time. Okay, and they come in the form of y equals some number. Now, to find the horizontal asymptotes, we compare the degrees of the numerator and denominator. So remember, the degrees is those are the highest exponents on top and bottom. So you got three cases. Case number one, the top degree is greater than the bottom degree. If the top is bigger than the bottom, it will have no horizontal asymptote because it wants to just keep heading towards infinity, okay, or negative infinity. But if the bottom degree is greater than the top degree, then over time, this wants to head towards 0 so that we get y equals 0. So before I do this other one, I just want to put a picture here. On these graphs down here, these vertical lines are the vertical asymptotes. So they show me where this function was undefined at. And notice it can't cross over that line. It goes straight up forever, and this side will go straight down forever, but they'll never cross that line. Now a horizontal asymptote, these little lines to the right, that would keep trying to get down to that 0 on the x-axis, but it never quite gets. Sort of like this one back here, it's pretty good. See how this line just keeps curving? It wants to get really close to the x-axis, but it never does cross over it, okay? All righty, then I had my third case. What if they equal each other? Top degree equals the bottom degree. If they are equal, then y will equal a over b, where a equals the top lead coefficient and b equals the bottom lead coefficient. So what I'm going to do is show you maybe how to do one or two of these problems, and we will figure stuff out on Wednesday. So I'm going to find the vertical asymptotes of the function. So y'all, they're giving me f of x equals x minus 2 over x squared plus 6x. So this one would be just like doing those domain problems. I'm going to take that bottom and set it equal to 0. At this point, we could use the quad because we got a quadratic equation. If you use the quad, let's see, a would have been 1, b would have been 6, and C would have been a 0. If you use the quad, you'd have got 2 answers. You would have got a 0. You would have got a -6. So that my vertical asymptotes are x equals 0 and x equals -6. So really, once you got the 2 answers, you don't do nothing else. You just write x equals that, x equals that. But you got to put the x's in here because they want them in equation form, okay? You can't just put 0, -6 because they'll mark you wrong. It's got to have that x equals.
Dang. Okay. Even on the test, it's gonna be like that because it's probably gonna be like very critical on the test, huh?
Yeah, I'll think about it. I might take it as x equals 0, -6 where you didn't have to write it twice.
Yeah. It's just gonna be a little different, man.
Yeah.
Yeah, that's why I always make this one take home. Oh, asim. Well, I always misspell that. I want to put 2 S's instead of 1. So I'm going to do a couple of these ones real quick. So my first one, I got f of x equals 3x to the 4th plus a 4 over 5x to the 4 minus 2. So remember, horizontal asymptotes, I got to look at the degrees. So is the degree on top bigger than the bottom? Is the degree on the bottom bigger than the top? Or is the degree on top equal to the degree on the bottom? So on this one, the top has a degree 4. The bottom has a degree 4. So the degree of the top is equal to the degree of the bottom. So that told me when they were equal, that it was going to be y equals the ratio of A over B. Well, A was the lead coefficient on top. The lead coefficient on top is a 3. B is the lead coefficient on the bottom, and the lead coefficient on the bottom is a 5. So over time, that's telling me that my horizontal asymptote is going to try to reach 3/5 on that, okay?
But it won't ever go past it.
But it won't ever get past it. There you go. How about this? F of x is a x squared minus 8 over 4x to the 4th plus 5. So who y'all say got the higher degree this time?
The bottom.
Definitely, because you got a 4 down there and the 2 on top. So the top is less than the bottom, which means the bottom is greater than the top. We said that this was y equals, what was that, case number 2? So y should equal 0.
So when the top one's bigger, when we're looking for the horizontal asymptote, that means there's not one, right?
Say again now.
I said when
what's
the
this?
top, the new.
So how about this one? This one has what? The top is bigger.
Mm-hmm.
So the top is bigger. So what are you going to say?
No, there's no asymptote.
There you go. And that's the 3 cases that'll hit you on those. They're either the same. You look at the numbers in front. The bottom's bigger, which goes to 0. The top's bigger, which means you have no horizontal asymptote. So we will get back into that 8.5 on Wednesday, okay? Because we get to learn how to graph and do all kinds of fun stuff with those.
Intermission.
All right, so what I'm gonna do now is, what is it, almost 1:30, so I'm gonna stop that. And, I'm gonna give y'all about, what, a 10-minute break, and then I'll do my support part of this, okay?
Okay.
Can't you use it? Oh, yeah. On that question about can you use the table to find the zeros? If you graph it, yes.
Yeah, that's what I was saying. But I mean, I figured it out when you showed it out. You showed
Okay.
it out.
Okay. All right, I'll see y'all in about 10 minutes.
Dang, who's jamming?
I got thoughts that are driving. Meth. And I'm aggravated without it. All right, let me send my back bet.